For my reflective assignment today I'm going to discuss about Hammett plot, which I first elaborately get in my module 4, which is one of the linear free energy relationship. And I from the lecture I found that this can create a relationship between the substituent and their effect on reaction rate, but it was new to me, so I didn't get it, and I did not understand substituent uh, how can a substituent have an effect on the reaction. So I just start surfing in the Google and watching various kind of video, and then I eventually understand that the basic reaction equation can be two types. One is the first one, which is depend on equilibrium constant, and the second one is depend on the reaction rate. And in both cases the log equation, and there is a row which is the reaction constant depend on the type of reaction, and the sigma where the which called substituent constant, which depend on the specific substituent. And those equation are just get from a simple reaction, which is ionization of benzoic acid. That's give me much more interest, that how can a simple reaction we can compare with other reaction and get the knowledge of substituent effect and the reaction knowledge. Then I start reading more and just learn that we can easily determine the pK of, and from pKa we can easily determine the substituent constant. And this substituent constant, I just example here the pK of benzoic acid 4.2, and if we used here in the para or meta position, this is also new to me, that I cannot explain it through ortho position due to steric effect. So it gives me another knowledge if the substituent in para or meta position, for example para nitrobenzoic acid, where the pK is 3.42, this gives much more acidic substitution reaction, because nitro pull the electron and so stabilize the carboxylic group here. So it is favoring the production of dissociation and much more stable carboxylic group, and this is more acidic. And para-methoxybenzoic acid, which is electron donating group, where the pK is 4.47, which is less acidic. And meta-chlorobenzoic acid, where the pK is 3.83, which is acidic but not as nitrobenzene. So uh, substituent constant can easily determine from here. I give the example of paranitro, where the rho is 1 for benzoic acid, and the value just putting here I can get the 0.78, and I can easily say that paranitro has increased acidity by 0.78 pK from the benzoic acid. Para-nitrobenzoic acid has increased acidity by 0.78 pK than benzoic acid. And also from here, simply putting the substituent constant and the log k x by ka in the graph, I can find the rho value, which is rate constant. And this is another uh, uh, important fact, that because most of the get either it uh, we get matter position, or we give electron donating or electron withdrawing group, most of the time we get a linear relationship, either the row can be positive and negative. Then it comes how the positive row and negative row effect. Then I just learned that if the row is more than one, the that gives a more sensitive to substituent than benzoic acid, and negative charge is built, and in that case a stable carbon ion. And if 0 to 1, less stable carbon ion. And then if 0, no positive or negative charge built. And if it's less than 0, then stable carbocation and the positive charge is built. So from here I learned that I can explain either this reaction is SN1 or SN2 because large negative rho value have big effect on stabilizing carbocation and that favor SN1 reaction than SN2. That knowledge we also used in our group presentation where we also explained the Hammett plot and also did that knowledge helped me in solving the row value in the midterm. I think by this way, this helped me a lot. Thank you.